Welcome to Never
Well,
Rewrite. I'm Isaac Askew.
Dustin Rea.
and I'm Jeffrey Sherman, and today we're going to discuss MVPs and the Goldilocks problem. Isaac, you brought this one up. Do you want to kick it off?
Yeah, so I guess my main thing I've been complaining about is I've seen the case many times where a company will try to build an MVP and developers essentially will argue about what the MVP looks like and how to code it. So there'll be a lot of opinions to essentially what I think is over-engineer the MVP to handle many cases
Hmm.
that could happen. They don't have these cases yet. There's just a lot of forward thinking of, oh, well, if this takes off, then this should be able to do this, and then we'll have to redesign it to do that. So we may as well go ahead and overly abstract these things such that when these inevitable things do happen, we're ready for them. And my pushback is always, why don't we just write something simple that can do the job now, to do the job of the things that we know it needs to do in the moment, and not code for the future. So they're very long term forward thinking. I'm very short term MVP thinking, and there's generally a clash between us because I think they think I'm being lazy with it or just trying to write crappy code and ship it. And I'm not going that far. I'm just saying let's do the minimum thing needed to test to see if this thing's viable without spending too much resources in case it's not and we have to abandon the project.
Well, there's an interesting thing you said at the end, which I want to tease out a bit, is code quality versus refactor or future growth. And those two things are not inherently related at all. Like you could write excellent code with 100% test coverage that solves one problem and one problem only, and you would have to do a massive refactor to make it solve two problems. And that's okay. Or you could write code that solves all the problems and has no tests, and it would be a steaming pile of junk, but it could solve anything. And, sorry, Dustin, it looked like you were about to jump in.
No, go ahead. I'll let you finish if you want to.
And so I don't agree with the idea of that you've got an MVP and the amount of abstraction. There's a developer I used to argue with maybe a decade ago. He would say I was being too dry, and he was saying YAGNI. If you haven't heard this, so dries don't repeat yourself. YAGNI is you ain't gonna need it, where you abstract and build stuff that you're never gonna use because what you think you're gonna use later isn't how you would actually build it later anyway, because you imagine the use case slightly wrong. And what you're describing seems like a case that actually is YAGNI of, hey, you're building an MVP. You don't know if anybody wants this feature. And if they do want it, you don't know how they're going to want to use it. So how would you possibly abstract to future use cases when you don't know what they look like?
Right. So therein lies the Goldilocks problem. I feel like there's a sweet spot of trying to ship the minimum thing that you need that is very specific and solves a problem versus somebody who's like, okay, well, oh man, if this thing does take off, the way we've coded it now is going to require a lot of refactoring and restructuring such that it might be very difficult to do. So I'm going to go ahead and really abstract the things that I think are the most likely to change such that when that moment comes, it'll be easier on the team. And I lean way towards the YAGNI piece to see, like, I want to see if this project's got legs before we sink a lot of money into it. And I think from their perspective, I think maybe it's about the code quality and how well can it scale should it take off. And in my head, I'm like, 99% of these things fail. Why would you even worry about it? Should it take off? That's just it'll be great if it took off. That means it's working and people are paying for it. Then we can worry about that. Otherwise, and I guess the reason this is kind of brought up is, like, I would say like 4 out of the last 5 projects that this particular company is working on, there were big projects that either never got to production or they released and they ended up getting sunset because there was not enough demand, or they they weren't successful in that we continued them. We decided, okay, we're going to take off people from working on that and try something else. But a ton of time was spent. We're talking weeks and months of planning, architecture diagrams, clean code abstractions,
Ugh.
and I think it was just overdone.
Yeah, well, clean code and abstractions, I don't. Though to me, those are different things. Where you can have clean code, and right, like if you the minimum there is I think being lost. Where all of this stuff, like if you're writing code and you write, test highly testable code, and you write tests for your code, then your code is going to be fairly easy to refactor, and you're going to be able to
Right.
consider how it all works, and it's going to be very composable, and it will be easy to compose it differently to add, to create seams and add these things. And so the idea that, oh, no, 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 we need to make sure that the abstractions are correct. Like, you don't even know what the abstractions, you don't know what it is. How would you possibly know what the abstraction is?
Right.
But none of that prevents you from writing good code.
Yeah, what I'm seeing you talk about, Jeffrey, is I'm writing down the difference between maintainability and
Mm-hmm.
optionality, right? So, like, the
Mm.
way I'm seeing it as I can write really clean code that was maybe more time consuming than what we would call like sloppy MVP code, right? And that doesn't mean that I have all of the optionality. If the product needs to change this way or change that way, I still need to do a refactor to get there. That refactor is easier because I
Mm-hmm.
wrote very maintainable code. But I think what I see a lot of both engineers and product managers do is they want to build in optionality, like not
Yeah.
just like one either for the
Yeah.
product, but I see
That's a
engineers
great
do this all the
distinction.
time where it could go this way or this way or this way, and we've coded for all three, but it could only possibly be one in the future at a time. And right now, it's only the one that we know about. So, like, why are we even solving for cases that we're not
This
currently making money with yet?
this is
Yeah.
exactly that's a really good call out. That the
Yeah.
optionality piece is exactly the piece that's
Great
really
explanation.
really ribbing me right now. Because I'm
Yeah,
like, why are we
there's
coding for this optionality? Yeah.
there's a really good parallel to this that I've seen in another type of software engineering, and that's in game development and game design.
Mhm.
We don't do this much in the web app world, but I actually think there's a future. Imagine an admin panel for a product manager, right? Where it's like, so it's not just the programmer going in and saying, well, today the Stripe fees at 3%. I'm gonna, if they want to change it, it's a code change, right? So like that would be to me something that is maintainable but doesn't have optionality. But if I wanted to give the product manager the optionality to change that, that's a much bigger project, but I could build for that. And now the product manager can say, that they can change that value at any time. So what I wrote down is like, it's the difference in stage that either the product or the team is in, however you want to think about it. And
Mm-hmm.
it's like, are you trying to validate your product or are you tuning your product? Right. If you're in the validating stage, you don't need optionality. If you're in the tuning stage, you may want optionality because A or B may be, have a closer running from your research at that time, and then it becomes worth it because you need to move really fast because you're so close to it or whatever. But I
Right.
think in the
Mm-hmm.
validating stages, you don't want optionality. You do want maintainability because you do want to be able to change it quickly and safely. That's my thought.
Yeah. What you're saying about optionality resonates. It's triggering warning alarm bells in my head of where rewrites often get into trouble, where you've got some system that was okay, and then it got refactored and refactored. It became unmaintainable, and like, oh well, we're going to do the rewrite, and the main thing that the rewrite is going to have all the optionality to support
Right.
all the use cases. And once we built all this optionality with all the use cases, then it's going to be very easy to migrate from the old system to this new system that we've just written. And then it's not, because the optionality
Right.
doesn't help you.
Right. So I think that's a really good distinction there. That might be a term that I use going forward is optionality. Why
Yeah,
code
it's
for
really good.
optionality when we're still testing viability at this current
Right.
stage?
Yeah.
To me, that's premature optimization. And I always throw out the Sandy Metz book where she talks about if you've just got a street bike class that you're writing, there's no need to go ahead and make an abstract bike class and have the street bike extend from the bike class and try to
Right.
worry about what would the common behavior look like. Just worry about the street bike, and then if a mountain bike comes along, maybe even still you don't do that. And I forget what the third bike was. It's the one where you're lying down and you're pedaling.
Recombinant.
Yeah, recombinant bikes. Once that one comes along and you're like, okay, now we've got 3 cases and we can see a little more of a pattern of shared behavior, then we worry about all this kind of stuff. That way you're not wasting so much time trying to over abstract something that might not even need that, just for the sake of. And when I say clean code here, Jeffrey, I think that's what we've been hung up on that term a couple of times. I just mean like this beautiful concept of academically perfect code that engineers are taught. Like stop trying to make things this like pristine, polished thing. It's
I
not
was
even
thinking
live
clean
yet.
in terms of like, well written with tests, and you're talking about clean as in academic theory.
Yeah, I need to make that distinction because we have a lot of vocabulary issues
Yeah.
when
Yes.
it comes to.
But from a practical perspective,
things.
I've heard that rule
Yeah.
of 3s before. Of like, even
Yeah,
for,
it's a
like, when we're
classic.
talking about drying. Yeah, it's like you don't really want to dry things up and too much until you've used it 3 times. Okay, now we need to figure out what's the shared functionality.
Yeah, I will repeat myself twice.
Yeah.
Because but 2 times is not yet a pattern to me.
Correct.
And so I'll wait for the third one. I'm like, okay, now it's looking like a pattern. But either way, so what do I do for to go back to my team? We're not aligned.
Right.
Part of my team is like, no, it seems like they're terrified that we'll take off. So we have to make sure.
Well,
to
use
handle
the
all these
probabilities,
cases.
right? So you can say,
Yeah.
well, the probability of like needing this optionality, like
Yeah.
what's the ratio of like the likelihood that it will take off versus it won't? And it's like it reminds me of like Schrodinger's cat. It's like you have Schrodinger's optionality. Like you have optionality for stuff you don't know if you yet need or don't need. So it's like,
Right.
why even worry about it? Like
so to add a little more color to this picture and why there might be, I'll call it coding trauma. There's some coding trauma at this company.
Yeah.
And we have one route that was taken where a ton of stuff went into something, spent a year on it, and it flopped. And it failed bad. We hired a lot of people for it, and there was layoffs. So then we went all the way 180 and went, okay, well, we're just going to just do an MVP this next time. And then just bare bones, because we don't even want to overhire for it in case this happens again. So we're just going to a couple people work on it. Then that one actually took off and was very successful. And then one person had to spend a year trying to make it scale the right way because it was built so quickly in a non-scalable way to test it for viability that it was super difficult to change it later. And so there's this fight back and forth of we've experienced both ends of the spectrum. And the most recent trauma is I had to spend all this time trying to architect this differently to make it scale, and I don't want to do that again because that would hurt. And now we're trying to find the Goldilocks spot.
I think is the answer. We use this technique. We use this like I learned this in political science a long time ago in college. But like if you game out the scenario, so like right, if you're at the start of the project, you can say, okay, well, if you have kind of like this divide on like 2 ends of the spectrum, what's the reality is the truth is probably somewhere in the middle. So if you can find a place where you're both like happy, so like I think what you want to do is you game it out and you say, well, what are the worst possible outcomes? What are the best possible outcomes? And like, can we plan for like the worst and the best or something like that, right? Like, so you have kind of like both things planned for as contingencies, but it doesn't impact your current like work cycle. So it's like if things take off, then we know we need to have these actions like ready, like lined up, whether that's maybe you have the hiring, some of the recs like already written or like ready to post or something like that. So then you can like make those actions really quick depending on if it's A or B path.
Jeffrey, you look very conflicted.
I was going to say something similar to what Dustin was going with, but possibly not as nice, which is if you build an MVP and it takes off and then you are scrambling for a year because you wrote it in a way that doesn't scale, I don't know that I would believe that you could write an abstracted version of the same thing in a way that's going to scale correctly. Because to me, like if I was going to build a product, right, and it's a web app, and I'm going to build this first thing, and it would just be straight CRUD, right? I don't know, I'll do total lamp stack. I'm going to do EC2 instances of Linux running Apache with PHP and MySQL on the back end. And if that takes off, that I know how that scales. Like that, you put, I might put in Redis to do some caching. I'll make the EC2 instances bigger. I'll do all, and if those standard things aren't going to work, like if I needed to spend a year gaming out and totally refactoring what I did to go from a CRUD app to a scalable CRUD app, I've done something. There's something wrong, and I wouldn't trust the person who got that wrong to build an abstracted version that would scale, like from the jump.
Let me add a bit more color there. First of all, when the thing took off,
Mm-hmm.
We got a lot of partners very quickly, and we had to support those and add new features for those partners quickly while trying to consider what the scalable thing looks like. So that added some time to it.
Mm.
Second, this thing was built in a scalable way within a year, and it is currently working and is successful now. So it was re-architected. It is working really well and is designed very well currently. So this person's a very great architect. I'm not digging at that.
Mm-hmm.
But the decisions that were made to scramble to get it out to begin with are the ones where like we didn't have time. So the product person's like, we need this person signed on. I don't care. What's the fastest way you can do it? And then they were like, well, we can do it this way, but that's going to bite us later. If they happen to have, double, triple, quadruple the volume that we expect. And that ended up happening. And they're like,
Mm-hmm.
and they were the ones advising, saying we shouldn't do it this way. And every time, due to budget concerns, due to whatever reasons, they kept getting denied and said, no, we're not going to do it that way. We're going to do it the quick and dirty way over and over again. And then once it finally was really big, they were like, I told you all this stuff was going to happen. And they're like, okay, well, you can change these things that you don't like about it to make it more scalable now that we've got some stability. And so they were finally given the optionality to go through there and do that. So it wasn't just a year of planning by itself. It was more of just like slow growth over time, or I guess a fast growth over time as soon as the product became viable. And then trying to, like, this person being told you got to support and add new features while you want to make it scalable too. So it was like they were torn in two directions, and that's what took a year.
I saw this play out at one of the hyper growth SaaS companies that I worked for when we were hitting like our product market fit phase. It was like we were just onboarding customers so quickly at that point, like because that's what happens. I mean, now it's hitting, it's super viable, it's selling, and it was kind of the same problem. Even though we're not talking about MVP, it was like a lot of the product had been built by contractors up to that point, and there wasn't a lot of like architectural thought. And then they, of course, once there were certain companies, they had like a line of different, like, let's call it this, like different groups of companies that wouldn't sign until we had X feature or X product or X thing like added to the suite. And that was one of the most like beautifully executed. I'm sure it was not as beautiful behind the scenes between the executives on how that would actually roll out, but our engineering leader did an amazing job of like really like pushing those features into buckets and saying, when we attack this, we need to attack this bucket at once. Like this is a whole product. It's not like just a check the box feature. Like this takes actual effort. And really having that conversation, which drove sales crazy, because of course, if you've seen in any revenue organization, obviously it's all about bringing in the numbers. So when you have some engineering manager being like, "Hey, you can't sell those clients. We can't support them, even though they're saying yes," and that's affecting their paycheck and their compensation. Like that's a pretty heated situation. So it's like you have to bridge that gap. But I think the way that they were able to do that, like I think the most effectively, of course, if you have a safe culture, that helps. But by showing everybody that this is in everyone's best interest, both for the customer, both for the sales rep, both for the chief revenue officer, and then both for the engineering org. Because he was like, I know if we try to push out these 4 or 5 different things at once, none of them are going to land correctly, and we're going to flub our shot. Like all of these people are right now on the outside waiting to get in. The power is in our hands, like so that like we now need to control the roadmap and make sure we're hitting the right bucket of customers, like the most bang for our buck. And then so they kind of did it like in a really sequential order. That was how they kind of did the political aspect of it. But then the how aspect of it, which was really cool, and I think most engineers would love, is we had to get that first product and the base right, because once you had that, you had the blueprint. And so it wasn't about, and this is like this will probably be on my tombstone. It's not about building the product at that point. It's about building the product building machine, right? So it's like once you have like the factory, now everyone has the same expectation, and you can kind of
Right.
scale horizontally the team and their effort and their output. And we were able to, ship out multiple products like within a span of like under 2 years and grow the team by 300%. It was massive, crazy time. I think it's kind of this similar aspect when you're first launching. There's kind of a tug of war between revenue and support.
There was, and there was a lot of saying yes to partners to features that we did not yet have, because that's what sales happens to do a lot. And can we do this? Ask the engineers real quick and say, yes, we've got that. And then we're scrambling to build it. And that's kind of how the second one played out there.
It's also worth pointing out that the second one is a good problem to have.
Yeah. Yeah.
Right. The second one is, there's money coming in the door. We can afford to do this thing. Whereas the first one is, there's no money coming in. We don't know if we can afford to do this thing. And if it's wrong, as you say, layoffs. Like there could even be layoffs as a result of this.
It's dangerous to get wrong. Yeah.
Yeah.
But to bring it back around, this is also a very interesting conversation. However, the main thing is the topic on trying to over-engineer this MVP before you have anybody willing to pay for it. Before this, trying to preemptively guess at the optionality that you think you will need, and over architecture code, making the delivery of your code take much longer per feature or per piece, because you're spending so much time thinking, oh, I can't code it that way because, oh, what if this happens? What if that happens? There's too many what ifs that don't let you launch very quickly. And by the time you do launch, either the customer's not there anymore, or the thing that you built is actually useless and no one cares about it. This is waste of resources. So that's there's something in there, that sweet spot in there, that I don't know how to get people to align on it. I think there's always like people like me who are like, I try to be short term thinking because I'm trying to gauge viability and I like being in that role. And there's people who want to pull in once the thing has legs that can help that long term thinking. But I think that there needs to just be an alignment on how far we were willing to go on this particular project.
Yeah, I think what I would push for is similar to what Dustin was saying of don't architect it, but game theory it. It's like, okay, we've got this thing, and okay, so and what's going to happen if the customer, we think they're going to use it for 1,000 things, and they need a 10,000 or 100,000. It's like, okay, how would we solve that? I'm not going to solve it, but like, what's the solution there?
Yeah,
it's like, oh, okay, well, we go from uploading having a form to uploading a file, and then like, oh, well, this file is so huge. Okay, well, then we'll have to make it asynchronous. And you just write down the answer, but you don't actually architect it or do anything. But then like you can calm people down. It's like, okay, well, we know what we will do, and it's like, okay, we're going to move from a form to a file to asynchronous file processing. That's how we're going to step it through. But we don't need to write any of that stuff there. So that's the interface. It's just like, okay, how are we going to process this thing? Because eventually it'll need to be asynchronous.
Right. I like that solution. So the idea, both of you describing, essentially going to anybody with those concerns, if they push back and say this thing needs to be a little more abstracted because of the what ifs, this, what if that, like just sitting down with them and saying, okay, let's play it out. Sure. Right. We'll write it down in a document. This is our goal. If this is the thing we're going to do next, if the thing that you're worrying about does happen.
Right.
Yeah. The other thing I was going to say too, when you're gaming it out that I didn't mention earlier, is like opportunity cost. Like what else could you build if you weren't building this optionality, and compare that in value. And I think that's another good way to be like, obviously we only need to jump this one hurdle right now. So we don't need to figure out how to jump 3 hurdles at a time, because like we don't have that problem yet. And I think business is the same. I say the same thing to founders all the time. Like, don't try to solve problems that you don't have yet. Like, it's all about solving the next problem right in front of you.
Yeah. So I think that's the main issue. Is I'm thinking it from the business perspective too, not just the coding perspective. And I really don't like solving problems I think I'm going to have. I like solving the ones
Right.
that are right in front of me. But
Yeah.
not to say I don't want to anticipate and be
Sure.
forward thinking a little bit to understand that I'm going to eventually face this thing coming up next. But just don't think I want to see a couple yards in front of me and not like 7 miles.
Right.
Yeah.
If it's not on the current roadmap, one way I think about it is if it's not on the current roadmap, I shouldn't be coding for it. Like if that optionality is like not literally like the next feature or something we know we're building in the next quarter or the next 2 quarters, then like, yeah, it's off the table. It's out of scope.
Right. But definitely don't just start chanting YAGNI, YAGNI, YAGNI. But
I'm really close to that, Jeffrey. I'm closer to chanting that than dry.
Yeah.
Yeah. Also, don't actually say that this is a Goldilocks problem, because they will understand the metaphor, but they will get upset that this is how you've decided to explain it. Gaming it out with them and writing down the answers so that you have a game plan or a run book for how this will scale and how you will answer these things is, I think, because that takes relatively little effort. It's worth doing.
Mm-hmm.
It's planning. It's planning instead of executing, because writing giant architectures is executing.
Mm-hmm.
Yeah.
Well, I'll take that to the team and we'll see
Give us an
how they
update.
respond. Maybe we'll have a part 2.
Yeah, there's an old joke that weeks of execution can save you hours of planning.
Yeah. I'm sure they'd like that as ammunition on their end. Anyway.
Awesome.
All right.
Thank you all for listening. I'm Jeffrey Sherman.
Dustin Rea.
And I'm Isaac Askew, and this is Never Rewrite.